Okay, so last time what we have done is the concept of soft iron rods, and we had looked at some conventions about the soft iron rods. So soft iron rods, the first convention was that soft iron rods don't have any weight. That means induction in them we will consider only along their length. Okay. Then soft iron rods are located either right forward, right aft, or just on the starboard side, or just on the port side, or just above, or just below the compass. That is the near pole of the rod is located in this way. The next one we have seen that near pole of the rod is taken as positive if it is located forward, starboard side, or below the compass. Otherwise, it is negative. And the other pole of the rod, that is the farther pole of the rod, is taken as positive if it is located forward of the near pole, starboard side of the near pole, or below the near pole. Then we had looked at that if both the poles of a rod are positive, rod is positive. If both the poles of a rod are negative, then also the rod is positive. And if one is positive, one is negative, then the rod is taken as negative. And the last one, I think what we had seen was that the rods are a very long length. That means we consider only the near pole of the rod to be effective at the compass position. So this is the point where we finished our last lecture. So now we will look at these 9 soft iron rods. So these rods are numbered, not numbered. These rods are known as A rod, B rod, C rod, D rod, E rod, F rod, G rod, H rod, and K rod. I and J letters are not used. Okay, and it is denoted by small letters, small a, small b, so not capital A and capital B. Okay, and basically we had seen that the ship is having 3 types of soft iron: horizontal soft iron, which I had said like girders, 4.5 girders. A broadsheet horizontal soft iron, we can say that is beams and bulkheads, and vertical soft iron, we can say funnel and mast. Okay, and these 3 can cause 3 types of forces at the compass position. One is the horizontal force, a broadsheet horizontal force, and vertical force. So these 3 multiply by these 3, that is how you get this 9 rods. So that is what we are going to look at. So this is the last point as far as the, or you can say second last point, which as far as the concept is concerned. After that, it is, as I said in the last lecture, it will be just application of what we have learned until now. Okay, so let us start. So how much space we should leave for, okay, we'll leave this much space by empty. Okay, so we have made these columns and rows, and now we can make a rows also. Okay, can you see the board clearly? Hello?
Yes, sir.
Yes, sir. Okay. So basically what will come here will come fore and aft horizontal soft iron. Here what will come athwartship horizontal soft iron, and what will come here is a vertical soft iron. The fore and aft horizontal soft iron, athwartship horizontal soft iron, vertical soft iron. Okay. Then what will come here? Creating fore and aft horizontal wheel at compass position. Creating fore and aft horizontal field at the compass position. Here what we'll put, creating athwartship horizontal field at compass position. Creating athwartship horizontal field at the compass position. And the last one will be creating vertical field at compass position. So fore and aft horizontal soft iron, athwartship horizontal soft iron, vertical soft iron. Creating fore and aft horizontal field at the compass position. Creating athwartship horizontal field at the compass position. Creating vertical field at the compass position. Okay. So basically, as you can see, what will come here? Here, what will come? Fore and aft horizontal soft iron, creating fore and aft horizontal field at the compass position. If I say what will come here? Athwartship horizontal soft iron, creating athwartship horizontal field at the compass position. If I say what will come here? Okay, athwartship horizontal soft iron, creating a vertical field at the compass position. Now, are these 9 rods have to be memorized, or it has to be there has to be some way in which you can draw at any time. So you can draw it at any time. Okay, and there's no need to memorize. Even I don't memorize. Okay, but I know how to draw it. Okay, so here what will come? A rod, B rod, C rod, D rod, E rod, F rod, like that. Now, as I said that it is always small a, small b, small c. And every rod will have plus a, minus a, plus b, minus b, plus c, minus c. So for showing these rods, we can use 3 views of the ship. This you can see, this is the plan view. So we can use either view, or the second view what we can use is the end view. End view means in this case the compass position is this. So this is the compass position. In this case, this is the compass position. So now in this case, we are looking at the ship from aft. So this is starboard and this is forward. And the third view what we can use is the side view. Side view means we are looking at from the starboard side. So this is forward and this is aft. And the compass can be shown. Is this understood? Hello? Hello?
Yes, sir, understood.
Are you able to see the full board? Hello?
Yes,
Are you
sir.
able to see?
सर थोड़ा ऊपर का नहीं दिख रहा है स्टारबोर्ड साइड
Now?
ओके सर
Yes. You can see the full board?
यस सर
Okay. So we can use plan view, end view, or side view. So only so which is the view we have to use? Okay, that we can easily find out. Okay, so like now the first rod, what I'm going to say is the 4.5 frontal soft iron creating 4.5 horizontal field at the compass position. That means the soft iron also we can have to show forward, and the field also have to show forward. So which is the view which we'll be using? We'll be using the plan view. We use the plan view. Okay. So this is the compass position, and the rods are mostly in the like this. So you have the rods are in pairs. One is like this and one is like this. So this is called divided 4.5 horizontal soft iron. Divided 4.5 horizontal soft iron. But I will not write here because it will get very clustered. Okay. So 4.5 horizontal soft iron creating 4.5 horizontal field at the compass position. So how did I draw like this? Okay. See, we have seen that only the near pole is effective. So I will just show it to you on the side here. See, 3, 4 I will explain to you, and then the balance of it you will be able to draw it yourself if you have understood. So if I am showing the same thing here, okay, the rod is like this. See, what is this? It is what is first what you have to see is that what is the field. Now, what is the field? Field is 4.5 frontal field. And we have seen in the convention that it is only the near pole of the rod which is effective. So if the field is 4.5, okay, then where will you put the near pole of the compass? 4.5, or you will keep it on the port and starboard or above and below. So if the field is 4.5, then where will you put the near pole of the compass? Here, forward and aft.
4.5.
And then after that, what you look at, it is the 4.5 frontal soft iron. That means this rod will be in the 4.5 direction. So because if you have put the near pole here and near pole here, then of course because it is a 4.5 frontal soft iron, so the rod will go like this and rod will go like this, correct? Okay.
Yes,
So first what we do, we choose the view, plan view. After that, what we see, look at that, what is the field? If the field is 4.5, we keep the near pole 4.5. If the field is a cross shape, we keep the near pole port and starboard. If the field is vertical, we keep the near pole up and below. After that, we are looking at that what is it a 4.5 frontal soft iron? Then we will draw like this. Understood? So how it will create? Let us say if a ship is having this and the ship is sailing in the northerly direction. So in the northerly, when the ship is sailing in the northerly direction, H is also acting in the same direction. So what will happen? There will be induction in this rod because it is a soft iron. Okay, it is receiving the induction from H. So this will become blue, and this will become blue, and the other end will become red, and this end will also become red. Now this blue and this red we ignore because these are the away poles. So now you have a red pole aft and blue pole forward. So the forces after these red poles and blue poles have been created, then the force will go from this red to this blue. So the force will be going in this direction. So what is this? This is a 4.5 frontal soft iron creating a 4.5 frontal field at the compass position. So that is what it is known as. It will be known as A rod. Or we can call it as a plus A rod because you can see this is forward. Forward is positive, and this is also forward. So this is also positive. This is aft, so negative. So the near pole is aft of the compass position, so this is negative. And the other pole is after the near pole, so that is also negative. So negative is positive, and positive is positive. This will be what? This will be plus A rod. Any doubt? Hello.
No, sir. Yes, sir. Understood.
Okay. Now here, what will be there? There will be one continuous rod. But as you can see, there is no other combination which is possible. So here, here, and here, you will have one continuous rod. Otherwise, all the rods will be in pairs. So what will be this? This will be random. So this is called continuous foreigner software. Okay. So इसमें भी induction क्या होगा? Let us say this becomes blue and this becomes red. So the force will be coming in this direction. This is also foreigner software, but it is a continuous one. Okay. So in this case, it is plus or minus. You can see. Then now here you cannot say which is the near pole or which is the other pole. If you take any pole as a near pole, let us say if I take this one as a near pole. If this is the near pole, so then this is forward of the compass position, so it is positive. So then the other pole, that is this one, is after the near pole, so this is negative. So positive and negative will become negative. If you take this as a near pole, then it is after the compass position, so it is negative. Then what about the other pole? Other pole is forward of the near pole, so it is positive. In that case also, this is negative and this is positive. So in either way, whichever you take as a near pole, one is positive and one is negative. So this will be minus A rod. Okay. Then now we come here. What is this? A throtship horizontal software and creating frontal field at the compass position. So which is the view we should use? Plan view, end view, or side view?
So plan view.
Okay, plan view. So I have drawn plan view. Okay. What is the field? What is the field? Because here what will come? A throtship horizontal software and creating a frontal field at the compass position. So in this case, what is the field? Hello, I want to keep it interactive. What is the field?
Sir, just port or just starboard of the.
See, the field is fore and aft, not just forward. Look, field is fore and aft, no? If the field is fore and aft, where we should put the near pole? Should we place the near pole forward and aft? Yes. So this is the near pole we are putting. Now what is the rod? Rod is a thrust shape. That means the rod is going in the thrust shape direction. Then what we'll do? We'll put one rod like this and one rod like this. That's it. Hello.
Yes, sir.
So we have chosen the plan view. After that, because the field was fore and aft, we kept the near pole forward and aft for the compass position. Then we have, because the rod is a thrust shape, so we have put one like this and one like this. So you can see that how it will cause the field in the fore and aft direction. So let us say the ship is sailing in this direction, and you have this rod like this. This is the compass position, and this is like this. In this case, the H is going like this. So it is a horizontal software that will receive induction from H only. What will happen? So then now the lines are entering from here and exiting from here. So this will become blue. And similarly entering from here and exiting from here. This will become blue. And now exiting from here, so this end will become red and this end will become red. Okay. So this one and this one, okay, let us say this one, because this is the other pole and this is the other pole, and we consider only the near pole to be effective. So the force flip going from this red to this blue, we make it slightly. So this will be red, okay, and this is blue. So this blue and this red and this blue and this red. So this blue and red pole we ignore. So now the force which will be passing will be from this red to this blue in this direction. So it is a thought shape orientation, meeting what field at the compass position, coordinate frontiers. Because you can see this field is acting in the R direction. So a thought shape oriented software creating a coordinate frontier at the compass position. Hello. So this will be positive or negative. So if you can see this is the near poles, it is located forward, so it is positive. And this other end is the starboard side of the near pole. So this is also positive. So positive and positive is positive. This is after the near pole, so it is negative. And this is after the compass position, so this is negative. And this is the port side of the near pole, so this is negative. So negative and negative is positive. So negative is positive, and positive is positive. So what will be this? A plus B rod.
Excuse me, sir.
Yes.
So when the rods are there, soft iron rods, that time when they are perpendicular to the magnetic, perpendicular to the field, that time they don't induce any poles, right, sir? This in
Yeah.
which in the fore and aft direction. That time
Correct.
the
Correct.
field is in, yes.
Yeah. So that is why I have not shown. That is why I have not shown you this. Okay. That is why I have not shown you this. In this case, there will be no induction. Okay, this is not. This I am taking a heading of, let us say 040. So in this case, there will be not maximum induction, but there will be some induction.
Okay, sir, understood. Thank you, sir.
Because see, this force H, Earth का magnetic field ऐसे direction में जा रहा है. So there will be one component of this will be going in this direction, and one component is going in this direction. So what this component will do? This component will induce the magnetism into this. Understood?
Yes, sir.
This is the Earth's magnetic field. So iska one of the component will be going in the athwartship direction of the ship, and one is going in the forward direction of the ship. So जो athwartship direct component होगा, that will induce the magnetism into this. Understood?
Yes, sir.
Okay. And this will not do anything. So when the ship goes in the, let us say, easterly heading, and the ship goes on easterly or westerly heading, let us see easterly heading, then what will happen? That time it will receive maximum induction. So this will become blue, this will become red, this will become blue, this will become red. So in this case, there will be maximum. In this case, there will be zero. But in this case, there will be something between zero and maximum. Okay.
Yes, sir.
Okay. So now we go to the next one. Okay. So now it is compass position. So the near pole is forward and aft. Okay, because the field is forward and aft. And now this one you have drawn to the starboard side, and this one towards the port side. So just change the direction. Now this one you can draw like this, and this one you can draw. You can see this is forward, so it is positive, and this is forward of the near pole, so this is positive. So you can see this is the forward of the near pole, so it is positive, and this is forward of the compass position, so it is positive, and this is the port side of the near pole, so it is negative. So positive and negative is negative. This is after the after the compass position, so it is negative, and this is the starboard side of the near pole, so it is positive. So positive and negative is negative. Okay. So negative and positive is negative. And here positive and negative is negative. This is also negative and this is also negative. So this is minus B rod. this is also negative and this is also negative. Okay.
So both are negative. That time it becomes positive, no, sir?
Right. So I was waiting for that question to come. Okay. Otherwise, I would have told you myself. Okay. So what happens that if both the poles of a rod are negative, if both the poles of a rod are negative, then the rod is positive. If both the rods are negative, then it is negative only. You understand? In this case, both the rods are negative. This one is also negative and this is also negative. That is why it is minus B rod. So what I had said that if both the poles of a rod are negative, let us say, like in this case, you are seeing this is negative and this is also negative. So this became positive. Understood?
Yes, sir.
Okay. So we got plus B rod and minus B rod. Okay. Now tell me, what will come here is the vertical soft iron creating a 4.5 horizontal field at the compass position. So which is the view we should use? Side view,
Yes, sir.
side view, plan view, or end view?
Side view.
Side view. Okay, plan view. Can you show fore and aft? No. End view, you can show fore and aft, but you cannot show fore and aft. In the end view, you can show vertical, but you cannot show fore and aft. So what is the view in which you can show fore and aft also, and you can show the vertical? Side view, correct? Okay, so we can use the side view. When we use the side view, let us say I create a side view like this. This is forward. Okay. Let us say the compass is here. Compass is here. Okay. Now, what is the field it is creating? It is creating what field? 4.5 frontal field. So where we'll put at the near pole. Near pole, I have to put 4.5. Right? I have to put the near pole 4.5. Because what is the field? What is field is 4.5. So I have to put the near pole 4.5. Now we'll look at the soft iron. Soft iron is vertical. That means the soft iron is vertical. That means one of them will go upward and one of them will come down. Okay. So we have, after choosing the view, we see that what is the field? Field is 4.5. So the near pole has to be 4.5. After that, we look at the soft iron. Soft iron is vertical, so rod has to be vertical. So you can see that how it will create a 4.5 frontal field. If you see here, let us say if I draw this diagram here, in this case here. Okay, and let us say it is here, and what I have drawn like this. So this is a vertical soft iron. So vertical soft iron will receive induction not from H, it will receive induction from Z. That is the vertical component of the Earth's magnetic field, which is Z, which will induce the magnetism in the vertical plane of the vessel. Okay, so what is the inducing field in the vertical soft iron? All the time it is Z. So let us say vessel is in the northern hemisphere. And in the northern hemisphere, the Z is always acting vertically downward. What will happen? The inducing field is coming like this. So in that case, what will happen? This will become blue, and this will become blue, and this will become red. So this will become red, this will become red. If we ignore this one and this one because they are farther pole, so the field at the compass position, you have red pole forward and blue pole out. So the field at the compass position will be in this direction. So it is a vertical soft iron creating a 4.5 horizontal field at the compass position. Understood?
Sir.
Okay. So now, whether it is positive or negative, that we can see. So you can see this is forward, so it is positive, and this is above, so it is negative. So positive and negative is negative. This is aft, so it is negative, and this is below, so positive. So negative and positive is negative. So this is also negative, and this is also negative. That means this is minus C dot. Okay, so just to bring a little bit of practical significance, what you see, have you seen the Flinders bar on the ship? Flinders bar, which is located for mostly forward of the compass, magnetic compass. Hello? That Flinders bar, what you see, that is basically to correct this C dot only. Now what we can draw? We can draw now. We can draw opposite of that. Okay. We can draw one rod like this and one rod like this. Okay, so one we have drawn here and one we have. So you can see here, this is forward, this one is forward, so it is positive, and this is below, so this is also positive. This one is positive. This is aft, so it is negative, and this is above, so also negative. So positive and positive is positive, negative, negative is positive. That means this is also positive, this is also positive. Okay, it becomes good. Plus C dot. Okay. Any doubt? Okay, so now we can come to this D dot. Now in this block, what will come? 4.5 horizontal soft iron. The 4.5 horizontal soft iron creating a 30 horizontal field at the compass position. So what is the view we should use?
End view.
End view में can you show 4.5?
So plan view, sir.
Plan view. Plan view is the correct. So we can use the plan view. And if you think wrongly, let us say you in your mind you are thinking that you can do it by end view, then when you draw you will not be able to do it. So we use the plan view. Okay, so plan view. So this is the compass position. Because the field is now upward shift, where should I put the near pole? I should put the near pole on the starboard side and port side. On the starboard side and port side, we have put the near pole. Okay. Now, what is the soft iron? Soft iron is 4.5. So what we should put? Rod should be going in the forward direction and aft direction. So one will become like this, one will become like this. So again, let us say on a heading of 045, this will become blue, this will become red. This will become blue and this will become red. We'll have red pole here and blue pole here. So the field will be going in the third shift direction. I can show it here. Let us say on a heading of 045. Okay, you are having one like this, one like this, and H is going in this direction. This I will already explain to you. This will become blue. Okay, so this becomes blue, and this becomes blue, and this will become red. So the force will be going from red to blue, so it will be going in this direction. You can see it is 4.5 frontals of iron, and what field it is creating at the compass position, a throat-shaped horizontal field. So this will come as a D dot. You can see whether it is positive or negative. It is starboard side of the near pole, so it is positive, and this is forward of the near pole, so this is also positive. This is starboard side of the compass position, so it is positive, and this is forward of the near pole, so it is positive. Positive and positive is negative. Positive. This is port side of the compass position, so it is negative. And this is aft of the near pole, so it is also negative. So negative and negative is positive. So this we can say this will be the D dot. And now what we'll do? We'll draw the minus D dot. So that now this one we had drawn forward, so now we'll draw this one up, and this one will draw forward. You can see this is starboard side, so it is positive, and this is aft, so it is negative. So this becomes negative. This is port side of the compass position, so it is negative, and this is forward of the near pole, so it is positive. This is also negative, and this is also negative. This becomes minus 0. The next one is E rod. E rod is a throat-shaped horizontal soft iron creating a throat-shaped horizontal field at the compass position. The field is also a throat shape, and field is also a throat shape, and the horizontal soft iron is also a throat shape. In this case, what is the view we can use? We can use plan view also, and we can use end view also. Okay, but we go in the order like where the plan view can be used. We normally use the plan view. Okay, so either or we can use end view also, but we in the books it is plan view. So one will be like this. Okay. So what is the field? Field is a throat shape. So the near pole will be like this and like this. What is the rod? A rod is also a throat shape horizontal soft iron. What will happen here? This will go like this. Okay. So a throat shape horizontal soft iron creating a throat shape horizontal field at the compass position. So what will happen? Similarly, on this heading, let us say a vessel is going on this heading. It is like this. So that what will happen? This will become blue, and this will become blue, and this one will become red, and this one will become red. So the forces will be going from this red to this. So a throat shape horizontal soft iron creating a throat shape horizontal field in the compass position. So whether it is plus D or plus E or minus E, it is plus E because this is starboard, so positive. This is starboard, so it is positive. This is also starboard, so it is positive. So this is port, so it is negative, and this is also port, so negative. So negative, negative is positive, and positive and positive is positive. So this will be your plus E dot. And what will be the minus E dot? Minus E dot, as I said, but in this case, what will happen? The minus E dot will be like this. We can say minus E dot. So whether it is positive or negative, it is negative because in this case there is no near pole and forward pole, other pole. If you take this one as a near pole, this one is a near pole, so it is starboard side, so it is positive. Then what about the other pole? Then the other pole becomes on the port side, so it is negative. Okay, so this becomes negative. If you take this as a near pole, so then it is port side of the compass position, so it is becomes negative. Then the other pole is starboard side of the near pole, so it becomes positive. So either way, it is coming out to be minus E. Okay. So now what you do is that this other four rods F, G, H, and I and J is not there. What you will draw here K. So you try to draw it yourself and see whether you are able to draw.
Sir, ये plus E rod, can you explain once more? Plus E.
Means how it became plus E.
Yes, how it became plus.
So this is starboard side of the near pole. So it is positive, and the other end is the starboard side of the compass position. So sorry, this is the starboard side of the compass position. So it is positive, and this is starboard side of the near pole. So it is also positive. So the positive and positive is positive. This is port side of the compass position. So it is negative, and this is the port side of the near pole. So it is negative. So negative and negative is positive. So the polarity of the near pole is given with respect to its position from the compass, and polarity of the other pole, which is not a near pole, is given with respect to its position from near pole. Okay.
Yes, sir. Thank you.
Okay. So you try to draw this F, G, H, and K rod yourself. Just see, giving you some time. Okay, so you have drawn some. Okay, so let's continue. In this case, here what will be putting? What will come here is a vertical soft iron creating a thrust-ship horizontal field at the compass position. So what is the view we should use?
End view.
Yes, correct. So end view we should use. We use the end view. Let us say we show it like this. Okay, so we show the end view. So the end view, let us say this is the compass position. Now, what is the field? Field is a thrust shape. If the field is a thrust shape, we should keep the near pole, port and starboard. Now, what is this? This is vertical. So vertical means one we can put like this, another one we can put. Okay. So what will happen? Then let us say the vessel is in the northern hemisphere in which the Z is acting vertically downward. So this becomes blue and this becomes red. Similarly, this will become blue and this will become red. So you'll have blue here and red here. So there'll be a force acting towards port side because of the red pole here and blue pole here. So it is the vertical soft iron creating a thrust-ship horizontal field at the compass position. Okay. So then what it is positive or negative that we can see. So it is starboard side, so it is positive, and this is below, so it is negative. It is negative. It is port side, so it is negative. Sorry, this is starboard side, it is positive, and this is below, so also positive. So it is positive. This is port side, so it is negative, and this is above negative. So negative, negative is positive, and positive is positive. This one we can call it as plus F rod. And opposite to that, we can draw it as minus F rod. This rod now we had put it downward, so now we can put it upward. This one we can put it downward. Okay, so this is this is on the starboard side, so it is positive, and this is above. Okay, so it is negative. So positive and negative is negative. This is port side, so it is negative, and it is below, so positive. So negative and positive is negative. So negative and negative. So this is becomes minus F rod. So next rod is coming here, G rod. So what is G rod? G rod is coming here. So 4.5 horizontal soft iron creating a vertical field at the compass position. So what is the view in which we can show 4.5 also and vertical? That is side view. Okay. So we can use the side view. What is the field? Field is vertical. So where we should put the near pole? Near pole we should put it above and below. So the near pole we have put above and below. Now what is the rod? Rod is 4.5. What we'll do? We'll put one like this. Okay, so 4.5 horizontal soft iron creating a vertical field at the compass position. So in this case, what will be the inducing field? Inducing, because it is a horizontal soft iron, the inducing field will be H. Let us say on one, this becomes blue and this becomes red on some heading, and let us say this becomes blue and this becomes red. So this becomes red and this becomes blue. So the field will be going in the upward direction. Okay. So it is the 4.5 horizontal soft iron creating a vertical field at the compass position. तो जितने भी ये वर्टिकल फील्ड वाले हैं, ये वर्टिकल फील्ड, दिस विल आल्सो क्रिएट व्हाट? दिस विल आल्सो क्रिएट a healing error. Yesterday somebody was asking na कि healing error का that we were doing, so this will also cause healing error. This is called G rod. This is above, so it is positive. Sorry, this is above, so negative, and this is forward, so positive. So this is negative. This is below, so it is positive, and this is aft, so negative. This is also negative, and this is also negative. This is minus G dot. And what we can do, we can draw just opposite to that. So now this one we have drawn forward, so this one above one we can draw towards aft, and this one we can draw towards forward. Okay, so this one is above, so it is negative, and this is aft. This is also negative, so negative and negative is positive. This one is below, so it is positive, and this is forward, so it is positive. So this is also positive, this is also positive. This is your plus 0. So this will not cause deviation, but this will cause healing error. Similarly, we can look at H rod. What will be H rod? H rod will be a short-ship horizontal soft iron, creating a vertical field at the compass position. So what plan we can use? We can use the end view. We can use the end view. Okay. So what is the field? Field is vertical. So where should we put the near pole? We should put the near pole forward and up. So we put the near pole here. Sorry, we should put the near pole up above and below, because the field is vertical. So what is coming in this column is a short-ship horizontal soft iron, creating vertical field at the compass position. Because the field is vertical, we put the near pole above and below. Now, what is the rod? A rod is, what is the soft iron? Soft iron is a short shape. So this one we can draw it towards south, and this one we can draw it towards south. Again, it will receive induction from H. So let us say this becomes blue, and this becomes red, and this becomes blue, and this becomes red, due to the induction from H. So you'll have red pole here and blue pole here. You'll have red pole below the compass and blue pole above the compass. It will create a vertical field upward. Okay, so this is positive or negative that we can see. So it is above, so it is negative. Starboard side, so positive, so this is minus. This is below, so it is positive, and port side, so it is negative. This is also negative. That means this is minus. Okay. Then we can draw minus plus H rod. For drawing plus H rod, what we do? This, the one which was drawn towards starboard side, this one we can draw towards port side, and this one we can draw towards. So this is above, so negative, port side, negative. So negative is positive. This is below, so positive. Starboard side is also positive. So both are positive. So this is plus etc. Okay. Then comes the last rod, that is K rod. K rod is vertical soft iron, creating a vertical field at the compass position. In this case, what is the view we should use? We can use the end view, or we can use the side view also. In this case, both the views we can use. But let us say we use the end view. Okay, so this is the compass position. What is the field? Field is vertical, so we put the near pole here and here. What is the rod? Rod is also vertical. Let us say we put one rod like this. Okay. So whether it is positive or negative, let's see. तो इसमें इंडक्शन कहाँ से होगा? इसमें इंडक्शन Z से होगा. So this becomes, let us say in the northern hemisphere, this becomes blue and this becomes red, and this will become blue and this will become red. So you have red pole above the compass and blue pole below the compass. So there will be field acting vertically downward. Vertical soft iron creating a vertical field at the compass position. In the vertical soft iron, all this, the inducing field is Z. In all these 6, the inducing field is H. So this is above negative, and this is also above, so negative and negative is positive. This is below, so it is positive, and this is also below, so positive. So this will be plus K rod. And minus K rod, as you must have guessed, will be through and through. This is your minus K rod. Okay. So if you take this as a near pole, so it is above, so negative. So then the other one is below the near pole, so it is becomes positive. If you take this as a near pole, so it is below the compass, so it is positive. Then the other pole is above the near pole, so it is negative. So if you take any one as a near pole, it will come out to be negative one. So this is minus K rod. So these three are basically causing the healing error. Okay, and all these balance 6, they cause the deviation. Understood? So this is the soft iron component of the healing error is caused by this. And hard iron component of the healing error is caused by that force R which you have seen yesterday. So any doubt? Hello?
Sir,
Yes.
sir, for this K rod, minus K rod, sir, can you explain again?
Okay. So minus K rod, it is, you can see here, here and here, you have one continuous one. Okay. So if you look at the positive and negative, let us say you take any pole as a near pole. Let us say you take this pole as a near pole. So because it is near pole is located forward of the, sorry, above the compass position, so this will be negative. Then what about the other pole? Other pole is below the near pole. So it is below the near pole, so it will be taken as positive. So then it will become negative. If you take the bottom one as the near pole, suppose you assume that bottom one is the near pole. So because it is below the compass position, so it is positive. Then what about the other pole? Other pole is above the near pole, so it is negative. So either way you take, you either whether you take the above pole as near pole or you take the below pole as the near pole. In both the cases, one is coming positive and one is coming negative. That means it is minus K dot.
Yes, sir.
Okay. Okay. Chalo, I think I have got one more lecture. So we'll continue after the break.
Okay, sir.
Hello, can you hear me?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so so what we have looked at: A rod, B rod, C rod. Okay, D rod, E rod, F rod, G rod, H rod, K rod. So all these rods, are they physical rods? Okay. Do you have anything which is above the compass? It is going forward, and below it is going aft, and on the starboard side it is going forward and aft like this. So these are not physical rods. Okay, they are not the physical rods, but this is just a way of showing the effect of the soft iron magnetism at the compass position. Okay, so we don't have anything like this कि compass के ऊपर से निकल के कोई एक चीज, something is going upward and some below the compass something which is going downward, or something which is going through the compass like this. Okay, so these are basically just the way of showing the effect. How? That is what we will look at. Okay. So what we have said that it is not the physical rods. So what are these? Just to see with an example, let us say let us say this is the ship. Okay, of course, forward and aft. Okay, and we have a compass position here. Let's say this is the accommodation, and this is the compass position. And let us say, let me draw the accommodation slightly. This is the compass position. Let us say forward of the ship, we are having a crane like this. It could be crane or derrick, or let us say crane only. So the crane is now in this is plumb in this position, and of course there will be a crane post also. This crane post, what we are not talking about, we are talking about only the jib part of the crane. And let us say this crane is made of soft iron. So, and let us say for the sake of simplicity, let us take that this crane is located right on the fore and aft central line of the vessel. That means if I am showing the ship like this plan view, okay, so that means the compass position is here. So this is the compass, and the crane position is here. That means it is both are located on the fore and aft central line. Okay, so it's not that the crane is here or here; it is here. Okay, so that will make it simple. So as you can see that this crane is that in this jib is neither vertical nor it is horizontal. So of course it will have it can have a vertical component. This is the vertical component of the crane, and this is the horizontal component. Okay, so this part we can say this is your horizontal software. So 4.5 horizontal software, this one, and this one we can say this is vertical software. So this crane, okay, we have this crane component, we have divided into two components. So this is you can say this is a soft iron which is neither fore and aft nor it is vertical. So we have divided this into two components: fore and aft horizontal soft iron and vertical soft iron. And now we can remove this because now we are dealing with a component of that. Now this fore and aft horizontal soft iron will receive induction from H, and the vertical soft iron component will receive induction from Z. So let us say you have this fore and aft horizontal soft iron has received induction. Let us say the red and blue poles have been created. in this and this. So due to this, because it is located forward of the compass position and also below the compass position, so the force due to this will be acting, let us say, in this direction. Okay, the lines of forces we can show, but we will not show the lines of forces. So due to induction in this 4.5 horizontal shaft iron, the field which is acting at the compass position is in this direction. Now this field is again not acting in a particular direction. Okay, neither it is 4.5, now it is vertical. So it will have a 4.5 horizontal component and it will have a vertical component. So this 4.5 horizontal shaft iron has created this field, which has got two components, 4.5 horizontal shaft component and vertical component. So now you can see this part has created this component and this component. So can we say this component, we can call it that 4.5 horizontal shaft iron creating 4.5 horizontal field at the compass position. So what rod it is, what rod effect it has created, which rod it has created. So 4.5 horizontal shaft iron creating 4.5 horizontal field at the compass position. So which rod it has created?
A rod.
It has created a rod, correct? Then we look at this component, 4.5 horizontal shaft iron creating a vertical field at the compass position. So which rod it has been created?
G rod.
G rod, right? So G rod effect. Similarly, if you look at that this other component, this vertical component, due to this vertical component also, the force will be acting somewhere in this direction because it is located forward and it is also located below. So field. So this will also have a vertical horizontal component, and this will also have a vertical component. So this vertical shaft iron has created this force at the compass position, which can have a further horizontal component and vertical component. So this component we can call it now that it is the vertical shaft iron creating a 4.5 horizontal field at the compass position. So which rod it is?
C rod.
C rod. And that this component will be vertical shaft iron creating a vertical field in the compass position. So that will be K rod, correct?
Yes, sir.
So K rod. So what happens that due to induction in this crane, the four rods have been created at the compass position: A rod, C rod, G rod, and K rod. Okay. If we replace this the crane from the 4.5 center line, let us say the compass is located here and the crane is located here. So then what will happen? So then it will have a horizontal component also. Then two more rods will come into picture. Hello.
Yes, sir.
Okay. So likewise, the different structures of the ship are creating these effects at the compass position, which is shown by this A rod, G, B rod, C rod, D rod, E rod, and F rod. Okay. So this total A rod effect and total K rod effect and total B rod effect and total G rod effect, what is present in the compass position, it is not being caused by one ship structure. It is being caused by different ship structures. So maybe this A rod is being caused by this crane, by this some other structures here, some other structures here, some other structures here. Okay. Finally, what we are interested in is that how much is the total A rod effect present at the compass position. Whether it is caused by crane, whether it is caused by mast, or whether it is caused by bulkhead, or whether it is caused by some beams, it doesn't matter. Finally, we have to analyze and see that how much is the A rod effect present at the compass position, how much is the B rod effect, how much is the C rod effect. It may have been caused by any of the ship structures. Okay, so what we finally analyze that how much is the C rod effect at the compass position, and that is how it is corrected. So it is easier to find out that what is the C rod effect at the compass position. Okay. It may have been caused by any ship structure, it doesn't matter. And then accordingly we correct it. Okay. So as I said, this A rod, B rod, C rod, D rod, they are not physical rods at all. This is just a way and means of showing the effect of vertical soft iron present on the ship, creating field at the compass position. So how to tackle that? Understood? Hello? So like you can see, just a simple crane has created these 4 rods. Similarly, other structures are also creating rods, other structures are also creating rods. So all structures are creating some rods, an effect which can be shown by these rods. And then finally, we can analyze that what is the total effect, how much is the A rod effect and how much is the B rod effect, and accordingly, we can think of correcting. If they are having significant effect at the compass position, then we can think of correcting it. If they are having negligible effect at the compass position, then we can ignore it. Is it clear? Hello?
Yes, sir.
Now, let us say a ship is sailing like this, and this is the compass position. So how many forces are acting at this compass position? Okay. Force P, force Q, force R. This is due to hard iron magnetism. Then forces due to A rod, B rod, C rod, D rod, E rod, F rod, G rod, H rod, K rod. So due to the shift magnetism, these are the forces which are acting at the compass position. These are due to hard iron, and of course these 3 are due to soft iron. So not these 3, these 9. And due to the Earth's magnetism, what is the force which is acting? Due to the Earth's magnetism, there is single force acting, that is H. Z is also acting, but Z is not playing any role as far as the giving the directional property to the magnetic compass is concerned. So all these forces, these 12 forces, what they are trying to do, they are trying to deflect the magnetic compass from the north. And the single force which is fighting with these 12 forces is H. H is always trying to point towards, take the magnetic compass towards north. What H is trying? It is trying the magnetic compass to be pointing always like this. And what these forces are trying? They are trying to deflect the magnetic compass like this. Correct? So if this force is strong, then it will. So anyway, that will part we'll see later. Okay. Is this part understood? So this is ship's magnetism. This is Earth's magnetism. But this is also caused in turn by Earth's magnetism also. But this is a, you can say, undesired effect of the Earth's magnetism, because Earth's magnetism is inducing the magnetism in the ship's structure, which are causing these forces. Is it clear? Hello?
Yes, sir, clear.
Okay. Now, are we going to affect study this all the 12 forces? The answer is no. Well, first of all, you can see that these 3 are creating, these 3 are vertical forces, so they are causing healing. So now we are going to see only the deviation part. The healing error comes into picture only when the vessel is rolling, all healed or listed. But this will cause the forces which are basically acting when the vessel is not rolling. So So then कितने बचे अभी 9 बचे. अभी are we going to study all these 9? The answer is no. Because some of them are causing the effect at the compass position, which is very, very less. On a merchant vessel, those rods present are very, very less. Like D rod effect will be very, very less. So then what happens? That no attempt is made to correct some of these rods, okay, because they are having a very small effect at the compass position. Okay, so any attempt to correct that may create more problems or may create more error, because let us say D rod, it is causing, let us say, a deviation of 0.4 degrees. But when we go to correct this, okay, let us say we end up correcting 1.5 degrees by putting the corrections. So now we have done actual value of D was 0.4, but how much we end up correcting? 1.5. So earlier it was causing only a 0.4. Now it is causing 0.9 more. That means it is overcorrected by 0.9. Because such a minute estimation is not possible. 0.4, 0.3, 0.3. Okay. So the one which are having a not so much effect or say insignificant effect at the compass position, they are not corrected. So where they will go? They will go and sit in the deviation curve. So in the deviation curve, what you make on the shape, there is a 3 components. One is the uncorrected component. Let us say D rod is not corrected, so that becomes a uncorrected component. And the second one is overcorrected component, and one is undercorrected component. So that overcorrected and undercorrected we'll see later on. Okay. So for the sake of simplicity, what has been done, that this has been divided into 4 groups. Okay. So whatever we have to study further, it has been divided into actually 5 groups, but mainly there are 4 groups. So all these PQR, A, B, C, D, E, F, similarly, they have been divided into groups. Okay. And some of them have been left out because they are not having that much effect at the compass position. So this group, what I'm going to write, group number 1, 2, and 3, 4, and 5, that you don't write anywhere because there's nothing like group 1, 2, 3, and 4, 5. This I'm just drawing only for the sake of explanation. And let us leave this group 1 for the time. Group 1 is also very, very small. And test that we'll see in the end. Let us say group 2. So in the group 2, which are the 2 we'll keep? In the group 2, we'll keep force P and we'll keep the C rod. Now, why have put the force P and C rod in group 2? Because the kind of deviation what they are producing at the compass position is similar. Because of the similarity of the deviation what they produce at the compass position, they have been put in group 2. So in the group 2, what we will see, that deviation changes with directly proportional to sine theta, where theta is force. So both of them, they produce a deviation which is changing with the sign of course. That means sine 0 is 0. That means on northerly and southerly heading, the deviation due to these two will be 0. As you can see, I've already told you, force P is acting, let us say, bow, and H is also acting towards bow. Angle between H and P is 0. Okay, so what is the deviation? It is 0. So on a heading, southerly heading, the deviation is 0. Let us say if you go on easterly heading, now the P is acting in this direction because P is a permanent force acting towards bow. H is acting in this direction. So now P is acting perpendicular to H. So it will have a maximum deviation. Okay. So here it will have maximum. You can see the deviation is changing with the sign of course. Sine 0 is 0 and sine 90 is 1. Okay. So similarly, here again we will put we'll put two of this component, and here the deviation will be directly proportional to cos theta. Here the deviation will be directly proportional to sin 2 theta, and here the deviation will be directly proportional to cos 2 theta. So group 2 directly proportional to sin theta, deviation will be directly proportional to cos theta, directly proportional to sin 2 theta, directly proportional to cos. So that is how the grouping has been made. And the group 1, the deviation does not change with change of force. So it is independent of the force. So you can say it is a constant deviation on all headings. Okay. So are we going to study with this as group number 1, 2, 3, 4, and 5? No. Okay. So let us take the example of P, force P. Let us say the vessel on which I am sailing, it is having plus P. Plus P means there is a force acting towards Coff. Just now we have seen, again we are seeing again. P is acting in this direction. H is also acting in the same direction. So there is no angle between H and P. So there is no component of P which is acting perpendicular to H. So the deviation is 0. Can happen here, goes here. So here P is in this direction, H is acting in this direction. What will happen? If you take the resultant of this H and P, the resultant is acting in this direction. So if this force P was not there, your magnetic compass needle would have been pointing in this direction. But because this force P is there, this angle P is acting in this direction. This is not force R, this is resultant. Okay. So your magnetic compass needle has been deflected by this much angle. So this is your deviation. Let us say the deviation what you get here is this again is we are doing it for the second time. Deviation it is coming here is 9 degrees east. If we go on a heading somewhere in between 000 and 045, 090, so that let us say we go on a heading of 040, what will happen? Now force P is acting in this direction. So you can see force P is acting in the northeast direction. It will have a not exactly north or east. You can say 040 direction. So it will have a northerly component and it will have a easterly component. What is direction of H? H is always acting in this direction. So this northerly component will add on to H, not cause any deviation. What will this do? This will cause deviation. So of course, in this case, force P is permanent force, so it is not changing. But only a component of force P, only a component of P is acting as a deflecting component. So deviation here becomes, let us say, 5 degrees east. So as you can see from the pattern, the deviation, let us say, if you go on a heading of 070, the deviation could be 7 degrees east. If you go on a heading of, let us say, 020, then the deviation could be 2 degrees east. And here the deviation is 0. Right? So as the vessel goes from 0 heading to easterly heading, the easterly deviation will continue to increase. Then when the vessel goes on this other side heading, then the deviation will become westerly. Right? Force P is acting in this direction, and now H is acting in this direction. So resultant is now going in the westerly direction. So the deflection of the magnetic compass is this, which is again, which is of course in the westerly direction. So this becomes 9 degrees west. Now let us say I want to correct this force P. So is it possible to measure this force P? No. So we are not able to measure this force P. The force P कितने न्यूटन का है क्या है? But what we can measure is the deviation what this force P is causing. Okay. So what we can analyze and calculate is the deviation caused by force P, not force P. Is it understood? Hello.
Yes, sir.
Okay, so if we correct the deviation caused by a particular force, okay, and we nullify the deviation caused by, let us say, force B, then it will also get nullified in turn. So now, what is the deviation we should correct? Should we correct this? Should we correct this? Should we correct this? Should we correct this? कौन सा correct करना चाहिए? So we don't have any choice. Basically, what is the deviation what we are able to calculate? Can we calculate these 2 degrees, 5 degrees, and 7 degrees? No, this we cannot calculate. Not possible to calculate these values. Of course, you will come to know these values after you have calculated this value. So what is possible to calculate is this one. So what is the possible to calculate is the maximum deviation caused by force P. That we can calculate by a very simple calculation. So it is not possible to calculate the deviation caused on different headings, but it is possible to calculate the maximum value of deviation. So what we are going to study is basically that what is the maximum value of deviation caused by a particular force. And that maximum value of deviation caused by a particular force is called coefficient. So what is coefficient? Coefficient is deviation only. But what is the specialty about this coefficient? Coefficient is the maximum value of deviation. So in this case, is coefficient 2 degrees, 5 degrees, 7 degrees? 9. So what is the value of the coefficient? Coefficient is 9 degrees. Understood?
Yes, sir.
So what is the significance of coefficient? Because it is possible to calculate the coefficient and correct the coefficient. That is why. So coefficient is nothing but maximum value of deviation caused by a particular force. Okay. So again, I am calling that coefficient is the maximum value of deviation, nothing but maximum value of deviation. Okay. Now, how to calculate the coefficient, that we'll see later on. But is the coefficient named as easterly or westerly? No. Coefficient is either positive or negative. This is coefficient. What about deviation? Deviation is either easterly or you have westerly. But the coefficient is not easterly and westerly. Coefficient is either positive or negative. So now you will see the significance of those positive forces plus P and plus Q and plus R minus Q and minus. All the positive forces will create positive coefficient, and all the negative coefficient, all the positive forces will create positive coefficient, all the negative forces will create negative coefficient. And these coefficients are named as coefficient. So instead of calling it group 1, group 2, group 3, okay, so there's nothing like group 1 and group 2. Instead, what is called coefficient A, coefficient B, coefficient C, coefficient D, and coefficient D. There are 5 coefficients. So entire magnetic compass is now correction is within the range of these 5 coefficients. And as I said, that coefficient is never easterly or westerly, it is only positive and negative. So how do we say that this particular coefficient is positive or it is negative? So let us say a vessel is having plus P. So for coefficient to be called positive or negative, you have to choose a heading. And what heading you have to choose? Just to the clockwise of the north. That means you have to heading just to the right of north. That means you can choose a heading, any heading between 000 and 045. Let us say we will continue to choose heading 015. So it is a heading just to the right of north. So now this is a heading. Let us say I have chosen a heading of 015. You can choose any heading between 000 and 045. So P is acting in this direction. Let us say vessel is having plus P. Now what will happen? It will have a northerly component like this and a easterly component like this. So what deviation it will have? Easterly or westerly?
Easterly.
So it will have easterly deviation. Okay. So on a heading just to the right of north, if the deviation obtained is easterly, then that coefficient is called positive. So on a heading just to the right of north, if the deviation caused is easterly, then that coefficient is called positive. You can see in a quadrant of between 000 and 045, if the deviation you are getting is easterly, then the coefficient is positive. Let us say if on the same heading, let us say there's another ship which was having not plus P, that was having minus P. Minus P means force acting towards stern. Now what will happen? Minus P. It will have a southerly component and it will have a westerly component. What deviation you will have?
Westerly.
Westerly deviation. So same heading 015. So then if on a heading just to the right of north, the deviation called is westerly, so then the coefficient is called negative. So you choose any heading between 000 and 045. If the deviation obtained is easterly, coefficient is called positive. If the deviation obtained is negative, it will be called, sorry, deviation obtained is westerly, then it will be called negative. And what is the value of coefficient? Value of the coefficient is nothing but the maximum value of deviation caused by that particular force. Is it clear? Hello?
Yes, sir.
Yes, sir. The deviations are A, B, C, D, and E. So this doesn't change with the change of deviation. This I have told you directly proportional to sine theta. This is directly proportional to cos theta. This is directly proportional to sine 2 theta. And directly proportional to cos 2 theta. Where the theta is the force of the ship. The total deviation on the ship. Total deviation, we can say, is equal to A plus B sine theta, B cos theta, B sine 2 theta, E cos 2. So this is the total deviation what you obtained. Where the theta is the course, and this theta in this formula you can put in 360 notation. Let us say if you are putting a heading of 220, so you put 220 here, 220 here, 440 here, and 440 here. Okay, so if you put in the 360 notation, of course it will take care of the sign. कौन सा plus होगा, कौन सा minus होगा, that will come automatically. Okay, so what we are going to start with? We'll start with this coefficient B. So 80% of the deviation is caused by this force B and coefficient B and coefficient C. On the ship, you can say about more than 80% is caused by this B and C. These are the two most important deviations. Sorry, coefficients. That is what we want. So now, whatever we have studied until now, we are just going to implement in a practical way. First coefficient what we write is coefficient B. Coefficient B can be divided into two parts. as you must have guessed. One is called permanent B, and the other one is called induced B. This is due to hard iron, this is due to soft iron. So in the short, this one we call it PB, and this one will be called IB. And I used here is small I, okay, not the capital I. But here PB is both capital. So coefficient B is divided into two parts. One is the permanent B, one is the induced B. Okay. So that what is the total B what the ship will have? It will be the sum of this permanent B and induced B. So now we look at the permanent B. Or as we call it PB. So for every coefficient, what we have to see first is the definition. Okay. So normally definition I used to display it on the screen, but I don't have that laptop on. So that definition I'll show it to you in the next class. But anyway, I can write it here. What is definition of permanent B? Okay. So coefficient permanent B is the maximum value of coefficient permanent B is the maximum value of semicircular deviation. Semicircular deviation. The coefficient permanent B is the maximum value of semicircular deviation, comma, deviation due to which varies as sign of SINE. So because when we write the sign that, so when we write SIN, then we have to write the angle. But when we write the angle, we have to write SINE. It varies as sign of compass force and is caused by one-half horizontal component of ship's permanent magnetic field acting at compass position. Okay. So my handwriting is not very good. Coefficient permanent B is the maximum value of semicircular deviation. Deviation due to which varies as sign of compass force and is caused by one-half horizontal component of ship's permanent magnetic field acting at the compass position. So all of you write down this. If anything you cannot understand what I have written, then you can ask me. From the next class onwards, I will display it on the Word file so that anything which you are not able to understand. Means understand in the sense that what is written in the text form. Hello, note it down.
Yes, sir.
So let us understand our definition. Coefficient permanent is the maximum value of deviation. So every coefficient is nothing but the maximum value of deviation. So that part you understood. So a new term which I have added, it is a semicircular deviation. Semicircular deviation is what? We'll see that two types of deviation. This we have discussed earlier briefly, but one type of deviation you will get like this. This is the course and this is the deviation. So here you have easterly and below this line we have westerly. So here is this is easterly deviation and this is westerly deviation and this is the course. We have 0, 0, 0 here. This is 180 and this is 360. Suppose this is 90 and this is 5. Sorry, 270. This is east and this is west. So as you can see, the deviation sign of the deviation is changing after every semicircle. So this is, you can say one semicircle and one semicircle. Okay. So this kind of deviation is called semicircular deviation. Okay, because basically it is sign is changing from east. So here it is all east and it is all west. The sign is changing every minute. Other type of deviation, what you will see, I will show in the same graph. That will go like this. So here you will have east, here you will have west, here you will have east, and here you will have west. This is called quadrantal deviation. Okay, because the sign is changing every quarter. Okay, so actually, when we show it, so we show it the ship's course like this. The ship's course we are showing it like this. So if I draw this black one, it will show like this. Let us say on all easterly it is, this will become easterly and this will become westerly. And this circle is representing what? Ship's course. 0, 0, 0, 180. This is easterly heading. This is westerly heading. You can see in this entire semicircle, it is easterly, and this entire semicircle it is westerly. And same way, if I show this red one here, then what will happen? This is the ship's course 0, 0, 0, 180. This is let's say easterly. This is westerly. So here it is east. Here it is west. Here it is east. Here it is west. Okay. East, east, west, west. This is what heading? This is the heading of this is 90. So this is 135. So here 135 is where? Like this. It is called semicircular deviation. Deviation due to which varies the sign of compass course. So that we will see that how the deviation is changing as per the sign of course. Because we will get this curve. So that is basically a sine curve. And is caused by foreign-frontal component of ship's magnetic field acting at the compass position. Basically, what is this foreign-frontal component of ship's magnetic field acting at the compass position? So what is that component? Caused by foreign-horizontal component of ship's magnetic field acting at the compass position. So what is that component?
P.
P. So basically, it is P. So this is the definition. Okay. Then the second one what we study for coefficient is what is the cause. So cause is here in the definition itself. You can see. So foreign-frontal component of ship's magnetic field acting at the compass position. So this part, okay, this red highlighted part is basically your cause. Or we can say, in short, we can say it is force P. So coefficient permanent D, what is the force which is causing this? This is the force P. Okay. We have looked at the definition, we have looked at the cause. Okay. Now we'll go to the third thing. Any doubt?
Sir.
Okay. So the third thing what we have to see that how the deviation is changing with the change of course. That also briefly we have seen earlier. Okay. So for permanent D, what we have to see that change in deviation, due to change of change in deviation due to change of course. When we say course, it is the compass course, of course. So again, we do the same thing which we have done it 1 or 2 times earlier, or at least 2 times earlier. Now what we will do, let us say we'll say that one vessel is having plus P. And now we will swing the vessel at the same place. Now we are not changing the ship's position. At the same place, we will swing the vessel on 8 points, and then we'll see that what is the deviation we are getting. This we have done it earlier. Let us say first we start with the northerly. Because the vessel is having plus P, P is acting in this direction. In which direction H is acting? H is acting in this direction. So is there any angle between H and P? No. Will it cause any deviation? No. So the deviation will become how much? Nil deviation. Or we can say zero deviation. But if this force P is not causing any deviation, then what it will cause? Will it add on to H? Hello?
Yes, sir.
And what H is known as? H is known as directive force because it is giving a directional property to the compass. So we can call this H as a we can call it, means we have called it already, this H as a directive force. So can we say that this force P is having an increase in the directive force? So what we can write here, increase in directive force. Okay. So because this force H is giving the direction to the magnetic compass. Okay. So this force P and is acting in the same direction as H. So it is adding on to the directive force. So we can say increase in directive force. Is it clear? Second one we can draw is steadily heading. Okay, so this we have drawn it earlier today also. But as I said, now we are just applying. Force P is always a permanent force acting toward the ship's bow. This is P. In which direction H is acting? Again, today only we have seen that this will become the resultant. This will become a deviation. So what this deviation will be? Steady deviation. Okay. So can we say in this case, can we say there will be a maximum steady deviation? On this heading, the steady deviation will be maximum. Hello? And what will happen to the directive force? Is there any component of P which is acting towards north?
No, sir.
No. So we can write here maximum steady deviation, and we can say no change in directive force. So on a steady heading due to force P, we are having maximum steady deviation and no change in directive force. Let us say we go on a heading of 045. Okay. So now force P is acting in this direction. This is the compass portion. Okay? This is the compass portion at which the force P is acting in this direction. So force P is now acting in the northeast, so it will have northerly component and easterly component. This we have done it today only. So this easterly component will cause the easterly deviation. And what this northerly component will do, it will add on to H. So can we write both the things? And here we can write easterly deviation and increase in directive force. Hello? So here both the things are happening. This component is causing easterly deviation and this component is causing increase in the directive force. Yes?
Yes, sir.
Hello? So now the increasing directive force here will be more or here will be more. Of course, this entire force P is adding on to H. The directive force here will be maximum. So here we can write, before the increase in directive force, we can write here there will be maximum increase in directive force. So maximum increase in directive. Right? Vessel goes on a southeasterly heading. Okay. It will have a southerly component like this. Force P is always acting toward the ship's bow. Ship's course is changing. So now we are having a southerly component like this and southerly component like this. So can we say easterly deviation? And now this component of P is acting opposite to H. So can we write reduction in directive force? Now if we go to the southerly heading, force P is always acting towards bow. It is not changing in direction and magnitude. So now entire force P is now acting opposite to H. H is always acting towards now. So can we say here in this case also the deviation will be nil deviation. And can we write that maximum reduction in directive force? Hello.
Yes, sir.
So balance 3, you try to make it yourself and just see. You should be able to make it. Otherwise, I will make after 2 minutes. Just try to make it yourself for 2 minutes. Okay. Southwest, west, and northwest. Should be able to make it. Okay.
Yes, sir.
Hello, can you see the board?
Yes, sir.
Yes, sir.
Okay. We can go to the southwesterly heading. Force P is acting in this direction. It will have a southerly component and a westerly component. Okay. So what this westerly component will cause? It will cause westerly deviation, and southerly component will cause reduction in directive force. Right? Force P is now acting in the south. Force P is now acting in the southwest direction. So it will have a southerly component and a westerly component. This westerly component will cause westerly deviation, and this southerly component will cause reduction in directive force. Now we can go in the westerly direction like this. So force P is acting in this direction. So now this entire force P is acting in the westerly direction. So of course it will cause maximum westerly deviation. And because no component of P is going in the north-south direction, so there will be no change in directive force. Okay. So if we go in the northwest direction like this, force P is acting in this direction, northwest direction, so it will have a northerly component and a westerly component. Again, this westerly component will cause westerly deviation. This component will cause westerly deviation, and this component will cause increase in directive. Okay. So if we draw a graph of all this, on the x-axis we put the ship's course, and on y-axis we put the deviation. So here it is 0 deviation, and above this we put x-axis easterly deviation, and below this we put the westerly deviation. So then what will happen? Let us say this is 180, this is 090, this is 270, this is, let us say, 045, this is 135, this is 225, and this is 315. Okay, so you can see starting from here 0. So starting with 0 here, then becoming easterly. The easterly deviation will continue to increase till it becomes maximum easterly here. So that part we can draw like this. So starting from here, increasing, and maximum easterly becomes here. Once the deviation becomes maximum easterly, then that easterly deviation continues to reduce till it becomes 0 on this heading. So that part will come like this. Okay. So this part is shown here, this part is shown here, and this part is shown here. Once the deviation becomes 0 here, then the deviation sign of the deviation changes and becomes westerly. So here it is 0 and it is maximum. So from here to here, that maximum westerly deviation continues to increase. So that part we can show like this. And once the deviation has become maximum westerly on this heading, so then the deviation will start reducing, or westerly deviation will start reducing till it becomes 0 here. So that part will be like this. Understood? So by plotting the graph for ship's course against the deviation, what is the curve we are getting? We are getting this curve. And you can, all of you are familiar with this curve. What is this curve? This is sine curve. What we are getting is a sine curve. So which proves that deviation due to coefficient permanent B is directly proportional to sine of compass coordinates. Or we can say directly proportional to sine of theta, where theta is a compass coordinate. Understood? So if we take more values, you will get, you can say just by taking only these few values, how can we draw a curve like this? If you take more values, you will get this curve. But we are showing only 8. As you can see, sine 0 is 0, the deviation is 0. Sine 90 is 1. The deviation will be maximum because that is the maximum value of sine. Sine 45 will be about 0.7. Sine 135 is how much? Again, minus, 0.7. Sine 180 is again 0. Okay, sine 225 will be minus 0.7. So same as deviation here, but opposite in sign. Sine 270 will be minus 1. So whatever the deviation you are having, same value, but the opposite in sign here. And again, sine 360 will again become sine 0, that is equal to 1. Here you will have easterly and here you will have westerly. So this normally we show by a circle. How that circle we show? Just now we have shown that circle. We show it by circle. Instead of drawing this graph or drawing this, in the short, we show whenever we have to use it, we show it by circle. So the ship's course is a circle. So this is the 0, 0, 0. This is 180. This is 270. And this is 090. So on the heading where the deviation is 0, so where the heading the deviation is 0, this one and this one. So the two places where the deviation becomes 0, that is the place where the sign will change from east to west. So that we draw by a line. So this one and this one, the deviation is 0, so that we join by a line. Okay. And you can see this entire here is easterly and entire here is westerly. It is a quick way of showing. If a vessel was having minus P, if the vessel was having minus P, then the things will become opposite. If the vessel was having minus P, then we will have the force in this direction. So here what will happen? Maximum westerly deviation will occur. Okay. In this deviation, what will happen? You will have westerly deviation. So if you draw a similar curve for the vessel having minus P, what is the curve you will get? You get this curve. You will have westerly here and easterly here. Right? This is for minus P. And this curve is for plus PB or minus PB. This curve for is for plus PB. Why it is plus PB? Because you can see just to the heading, just on a heading right of the north. This is the quadrant between 0, 0, 0 and 0, 4, 5. This is 0, 4, 5. What deviation we are getting easterly? So basically, this is a curve for plus PB. So plus PB is caused by plus P. And in this case, that one you can see on a heading just to the right of north. What deviation we are getting westerly? So this is minus PB. Minus PB is called by minus P. Okay, and how we'll show this circle like this? We will show this circle like this. West and east. This become east and west. This will become west and east. Okay, so what is the conclusion we got? That deviation due to coefficient permanent B is directly proportional to sine of theta, where the theta is a compass force. Right? Hello? Okay, so we'll stop here today. We'll continue. Okay.
Thank you, sir.
Okay, sir. Thank you.